In this problem, we're going to use the technique of simplifying the integrand. So I am going to divide both terms of the numerator by the denominator, and then simplify. So x over x to the 1/2 is x to the 1/2. And then 1 over x to the 1/2 is x to the negative 1/2. So then I take the antiderivatives term by term. Add 1 to the exponent. 1/2 plus 2/2 is 3/2. And then divide by the new exponent, or multiply by its reciprocal. Okay, add 1 to my exponent. Negative 1/2 plus 2/2 is 1/2. Divide by the new exponent, or multiply by its reciprocal. Okay, now I have a definite integral, the integral from -2 to 0 of 2x plus 4 over x squared plus 4x plus 5 dx. So what immediately jumps out at me is that the denominator, if you take its derivative, you get the numerator. So I'm going to work on the antiderivative of 2x plus 4 over x squared plus 4x plus 5 dx. And I'm going to work on this ignoring the bounds. Once I have an antiderivative, I'll go back and work on my definite integral. So let's see, I'm going to let u be the denominator, x squared plus 4x plus 5, so that du dx is 2x plus 4, which means that dx is du over 2x plus 4. And then I plug into my integral, and I get the integral of 2x plus 4 over u times dx, which is du over 2x plus 4. So my 2x plus 4's cancel, and this is the integral of 1 over u du, which I know is the ln of u plus c. And then I'm going to plug in my u, x squared plus 4x plus 5. The ln of x squared plus 4x plus 5 plus c. So now I'm going to evaluate my definite integral from -2 to 0 of 2x plus 4 over x squared plus 4x plus 5 dx. That is equal to my antiderivative, the ln of x squared plus 4x plus 5, evaluated from -2 to 0. Okay, so when I plug in a 0, I get the ln of 5. And when I plug in -2, square it, you get 4. 4 minus 8 is -4, plus 5 is 1. So I get the ln of 1. All right, so the ln of 1 is 0. So this is just the ln of 5. The integral of 1 over x squared minus 1. So the first thing I notice is that the denominator is factorable. So I'm going to rewrite the integrand as 1 over x plus 1, x minus 1. And then I'm going to use a partial fraction decomposition to rewrite the integrand as a over x plus 1 plus b over x minus 1. So I'm going to multiply both sides of this equation by the common denominator, x plus 1, x minus 1. So on the left, my denominator completely cancels, and I just get 1. And on the right, when I distribute my common denominator to the a fraction, the x plus 1's cancel. So I have a times x minus 1. And then when I distribute to the b fraction, the x minus 1's cancel, and I have b times x plus 1. Now, this equation is supposed to be true for all x's, so I'm going to pick some values of x. I'll pick some convenient ones. Maybe 1 is a good one. So I get 1 equals 0a plus 2b, which means that b has to be a half. And then another convenient x value would be negative 1. So I get 1 equals negative 2a plus 0b, which means a is negative 1/2. So I'm going to take my integral, 1 over x squared minus 1 dx, and rewrite it as the integral of a over x plus 1, negative 1/2 over x plus 1, plus b, 1/2 over x minus 1 dx. So this becomes negative 1/2 ln of x plus 1 plus 1/2 ln x minus 1 plus c.